What specific problem does SuperGPQA aim to solve in the context of existing benchmarks, and why is this significant for evaluating large language models?
SuperGPQA aims to address the significant gap in existing benchmarks that primarily focus on common fields like mathematics and science, neglecting long-tailed disciplines such as light industry and agriculture. This limitation restricts the practical significance of these benchmarks in evaluating the real-world professionalism of large language models, LLMs. By providing a comprehensive evaluation across 285 graduate-level disciplines with at least 50 questions each, SuperGPQA ensures a more thorough assessment of ILM's knowledge and reasoning capabilities. The benchmark's rigorous three-stage quality inspection process enhances its reliability, making it a challenging frontier for state-of-the-art LLMs, which have previously achieved high scores on less demanding benchmarks. This is significant, as it allows for a more nuanced understanding of LLM performance across diverse fields, ultimately pushing the boundaries of what these models can achieve in complex reasoning tasks.
How does the proposed SuperGPQA benchmark work? Please illustrate the methodology step by step, including details on the three major stages of data collection.
The proposed SuperGPQA benchmark operates through a comprehensive methodology divided into three major stages: source screening, transcription, and quality inspection. 1. Source screening. Expert annotators collect credible resources to ensure the reliability and difficulty of the raw questions. This stage emphasizes the importance of sourcing from high-quality materials, as early reliance on crowdsourcing annotators led to ineffective questions, wasting resources. 2. Transcription. In this stage, crowdsourcing annotators revise the raw questions into candidate questions. They translate non-English questions, convert them into multiple-choice format, and standardize the wording, ensuring clarity and academic rigor. This process also includes generating confusion options to enhance question difficulty. 3. Quality inspection. This final stage employs a rigorous three-step process involving rule-based checks, LLM-based evaluations, and expert reviews. Candidate questions are filtered for formatting issues, assessed for validity and relevance using state-of-the-art LLMs, and then re-evaluated by expert annotators to ensure high standards of quality and discrimination. Overall, SuperGPQA's methodology is designed to create a challenging and reliable benchmark that effectively evaluates the reasoning capacities of large language models across diverse graduate-level disciplines.
Can you provide a specific example of a question in SuperGPQA and walk us through how it was developed, including the roles of expert annotators and crowdsourcing annotators?
An example of a question in SuperGPQA could be a complex reasoning question from the engineering discipline, which requires mathematical calculations. The development of such a question begins in the source screening stage, where expert annotators collect credible resources, ensuring the reliability and difficulty of the raw questions. Once a raw question is identified, crowdsourcing annotators, typically undergraduates or master's students from top-tier universities, revise this question into a multiple-choice format, generating complementary confusion options and estimating its difficulty and reliability based on expert judgments and LLM responses. Following this, the question undergoes a rigorous three-stage quality inspection process, where suspicious candidate questions are identified through LLM responses, reviewed by expert annotators with unrestricted web access, and tailored to ensure they meet the benchmark's discrimination criteria. This collaborative approach ensures that the final question is both challenging and reliable, effectively probing the reasoning capacities of large language models.
What are the theoretical benefits of using SuperGPQA over existing benchmarks like MMLU and GPQA, particularly regarding the coverage of knowledge and reasoning capacities?
SuperGPQA offers significant theoretical benefits over existing benchmarks like MMLU and GPQA by providing a more comprehensive evaluation of knowledge and reasoning capacities across a broader range of disciplines. Unlike MMLU and GPQA, which primarily focus on common fields such as mathematics and science, SuperGPQA encompasses 285 graduate-level disciplines, ensuring that it addresses long-tail fields often overlooked in traditional assessments. This extensive coverage is achieved through a rigorous three-stage quality inspection process that guarantees the reliability and difficulty of the questions, with at least 50 questions per discipline. Additionally, SuperGPQA's challenging format, featuring an average of 967 options per question, enhances its ability to probe the upper bounds of state-of-the-art LLMs, making it a more effective tool for evaluating complex reasoning tasks. Overall, SuperGPQA's design allows for a more nuanced understanding of LLM capabilities across diverse knowledge domains, thereby filling critical gaps left by previous benchmarks.
How was the SuperGPQA benchmark validated? Discuss the datasets used, the metrics for performance evaluation, and how the results demonstrate its effectiveness.
The SuperGPQA benchmark was validated through a rigorous three-stage quality inspection process involving source screening, transcription, and expert-based quality checks. Initially, expert annotators collected credible resources to ensure the reliability and difficulty of the raw questions, which were then revised by crowdsourcing annotators into multiple-choice formats. The performance of various state-of-the-art SOTA large language models, LLMs, was evaluated using metrics such as accuracy across different difficulty levels and disciplines, revealing that top reasoning models like DeepSeek R1 achieved scores around 60, indicating the benchmark's challenging nature. The dataset comprises 26,529 questions spanning 285 graduate-level disciplines, significantly surpassing existing benchmarks in both scale and complexity. The results demonstrated that SuperGPQA effectively discriminates between model performances, particularly highlighting the reasoning capabilities of models in complex tasks, thus validating its design as a comprehensive evaluation framework.
What were the key findings from the results achieved using SuperGPQA? Can you provide specific accuracy scores and any notable observations regarding model performance across different disciplines?
The key findings from the results achieved using SuperGPQA indicate that the top-performing reasoning models, such as DeepSeek R1 and O1, 2024, 1217, achieved overall scores around 60, demonstrating the benchmark's challenging nature. Notably, instruction tuning significantly improved performance with DeepSeek V3 and Qwen 2. 5-72B Instruct scoring 47.40 and 40.75 respectively, compared to their base versions which scored 32.14 and 34.33. The results also revealed that reasoning-focused models excelled on hard questions, while chat-oriented models, like DOUBA01, 5, Pro 32K, 20,250,115, performed better on easy and middle splits, indicating a divergence in capabilities. For instance, DeepSeek R1 scored 63.59 on easy, 63.63 on middle and 56.87 on hard questions, while Qwen 2, 5-14B Instruct showed a decline from 44.82 on easy to 19.97 on hard. Additionally, the analysis highlighted that disciplines such as history and law exhibited high discrimination power, while STEM fields like engineering showed more convergence in model performance, reflecting the standardized nature of problem solving in technical domains.